Hi guys, today we're talking about solving problems involving rates of change. I'm going to try to do this video a bit differently. I'm going to just talk a bit about the main concepts and then do most of the examples on a separate video. So today we're going to solve problems involving rates of change arising from real life situations. Interpret an instantaneous rate of change of 0 being a possible maximum or minimum, and use the estimation of instantaneous rate of change to determine if a given point is in fact a maximum or minimum on a graph. So recall the instantaneous rate of change is just the slope of a tangent at a given point. So if we have a curve, something like this, okay, this is a cubic, we'll be learning more about that. You can see on this curve we have a maximum that occurs here and a minimum that occurs here. Now, in both of these cases, the instantaneous rate of change is 0 at the maximum point because, I should have it, let me try it again. Because the tangent point would be a horizontal line exactly at the max. And the same can be said for a min, that the tangent point exactly at that min, would be a horizontal line, which means that it would have a slope of 0. Okay, so that's why we know that the instantaneous rate of change should be 0 at a maximum and at a minimum because their tangents are horizontal lines. But the one thing that does change, however, is that in the maximum, right before the rate of change is 0, the slope is positive, and then the slope is negative. So if it's a maximum point, the slope should be a positive, then 0, right at the maximum. But then after the maximum, it should be negative. However, at a minimum, it should be m equals 0, but right before it'll be negative, and then afterwards the slope will be positive. So we're going to use this fact to determine whether given points are maximums or minimums. Okay, so we have this sinusoidal example here about Leonard riding a Ferris wheel. So his elevation can be modeled with this equation. Will he be closest to the ground at 55 seconds? So that's just a fancy way of saying, is t equals 55 a minimum? So what we're going to do with instantaneous rate of change is we're going to check the rate of change right before 55 seconds, right after 55 seconds, and if it's negative right before and positive right after, it could be a minimum. And then we're going to average those two to show that they would average out to 0. So that means that the centered interval would give you a slope of 0, so that the instantaneous rate of change is 0. That's what we're going to do. So step 1 is to estimate the instantaneous rate of change on either side of t equals 55 seconds. T equals 55. So right before, that would be between, we'll use an h value of 0.01. So that would be 54.99 and 55. So our delta h over delta t, our change in height divided by our change in time, would be our height at 55 meters minus the height at 54.99 meters divided by h, which is 0.01. So when you put that through, you get negative 0.00012184. So I put in 55, I get a number. I put in 54.99, I get a number. Subtract them, divide by 0.01, and I get this. Okay, now let's try after. So this is good news so far because that is a negative rate of change, which means that it was decreasing up until 55. So now if it's increasing afterwards, that would suggest that at 55 there is a minimum. So delta H over delta T. Now this is going to be between H at 55.01 minus H at 55. Okay, because we're doing the point after. Just lift this up to make sure you can see it with my face in the corner there. So when you put this in, you get positive 0.00012184. Okay, so that's good. So step 2 then is we're going to average the two rates of change, and they should be 0, okay, or very close to 0. So you'll notice that if we take this minus 0.00012184 plus 0.00012184 divided by 2, that's how you get the average, you get 0. So that is a good thing. So then our next step is to verify the proper signs, which I've been talking about. So this was negative, so it's a negative, then 0, then positive. So that looks like you're going down, then 0, then up. So yes, that looks like a min if you want to have that visual for yourself there. And then your last step is to conclude. Okay, so I'm not going to write it all because of this pen not being great, but you can say since you have a negative rate of change and a positive rate of change in that order, that average to 0, you can conclude that yes, t equals 55 is a minimum. Okay, so that's the most basic example. So I'm going to do example 2 on a separate video. What I want you to do now is skip ahead and read through these steps for determining max or min using rates of change. So read through these steps. Okay, these are steps that we just did. So make sure that you understand them and relate them back to the example. And then once you've done that, try example 3. Okay, so go back and now try example 3. Okay, you should get, in this case, that, sorry, I'm making you all dizzy probably, that x equals 30 is a maximum. So I want to see that you can, that's the most basic type of example. I want to see that you can master that before we move on to example 2 and example 4. Give it a try.